Our sun can be quite a moody fellow, can be generous, showering Earth with life-giving light and warmth. But it can also be destructive. It's unleashing deadly solar flares and coronal mass ejections that can mess up important things like our telecommunications and our electrical grid system. And those are just the things that happen here on Earth. It turns out that Mercury gets hit much harder than we do, thanks to its proximity to the Sun. The planet is blasted with a constant barrage of charged particles from the Sun, and that bombardment has led to some surprising discoveries about the planet's core. You see, the Sun's outbursts aren't the only thing bombarding Mercury. Scientists have long suspected that solar wind is actually blowing metals away from the planet's surface, which might help explain why MESSENGER found so little evidence of an atmosphere when it reached Mercury in 2011. But they haven't been able to figure out exactly what metals were escaping until now. In a paper published this week in the journal Nature, researchers presented new evidence that paints a clear picture of which metals are taking their leave of Mercury and how the planet's magnetic field plays a key role in their escape. It's a rare look at a part of space that is very hard to study because, well, no one wants to go there. Since launching spacecraft that can survive the hellish conditions near the Sun requires a lot of money and resources. As a result, scientists know relatively little about Mercury, despite the fact that it was the first planet discovered by humans thousands of years ago. We still don't have any solid information about the planet's core. All we have to go on are indirect clues like seismic data gathered by NASA's MESSENGER spacecraft, which found that Mercury has a liquid outer core and a solid inner core. But the makeup of these layers has remained a mystery. Scientists believe that Mercury's core is rich in metals like iron and nickel. But exactly how much metal is down there, and how big the core is compared to the rest of the planet, is a big unknown. That's partly because Mercury doesn't have a lot of atmosphere for us to bounce radar signals off of, making it harder to map the planet's interior. But scientists think that in addition to being made of metal, Mercury's core could also be the source of another mysterious feature. A tenuous atmosphere or a exosphere that was detected by MESSENGER when it arrived at the planet. There should have been a lot more atmosphere if Mercury had cooled down after forming billions of years ago. So something must be keeping it warm enough that some of the rock and metal on the planet's surface is still vaporized. And researchers have settled on the solar wind as the most likely culprit. These are the charged particles, mostly protons and electrons, that stream constantly outward from the Sun. When they collide with atoms in Mercury's shallow crust, they knock some of those atoms into the air, leaving behind ions. And those ions can make their way into the planet's interior, where they gather around the core and heat it up. Based on models of the planet's interior, scientists predict that if Mercury's core is rich in iron, then it should be emitting a fair amount of iron ions into space. So researchers looked for iron, and they found it. By measuring how often iron ions hit the top of Mercury's magnetic field, they estimate that the solar wind strips about 280 kilograms of iron from the planet every second. That said, Mercury's magnetic field isn't perfectly smooth. There are regions where the field lines come close together, and others where they're spread far apart. The team found that iron is only escaping in places where the lines are spread far apart. Where the lines are closer together, other stuff is escaping instead. To find out what, the team built computer models that simulated the magnetic field around Mercury, along with the planet's thin atmosphere. Then they could measure how often different kinds of ions left the planet's surface under a variety of conditions. And they found that different ions escape at different speeds, depending on their mass and how strong the magnetic field is at that particular location. The team then compared their Model S predictions with data from the European Space Agency's BepiColombo probe, which measured the speed of ions near Mercury. And they were able to confirm that these speedy ions were indeed being stripped away by the solar wind. They also found that the lighter elements like oxygen, hydrogen, and sodium were moving away from the planet faster than heavier ones like iron and copper. That means that the lightest stuff will escape first, leaving behind a residue that is richer in heavier metals. That tracks with observations of Mercury's surface, which show that the lightest elements have depleted over time. And all this fits neatly with the idea that solar wind is responsible for both stripping away atmosphere and heating up its core. Based on the rate at which iron is escaping from Mercury, the team estimates that the planet will lose half of its metallic core over billions of years. At that point, Mercury won't be able to support a magnetic field anymore, which will make it easier for the solar wind to strip away the rest of its atmosphere. And although this process will be different on Earth, It could also play a role in our planet losing its protective ozone layer and its magnetic field over billions of years. Understanding how solar wind interacts with Mercury, its magnetic field also has implications for sending spacecraft through this hazardous region of space. The solar wind can damage vital electronics and disrupt communications. So predicting how intense the solar wind will be in certain places would help keep future spacecraft safe. All of this is possible thanks to some old-fashioned detective work. Noticing that something is amiss in this case, Mercury's unexpectedly tenuous atmosphere, then running some tests and building models to figure out what's really going on. Of course, scientists don't always get it right. And while the solar wind hypothesis seems to check out, other researchers have suggested that volcanic activity on Mercury could be keeping its core warm, without any help from the sun. There may be other factors at play, too. Mercury's strange magnetic field, for example, could be trapping some of the ions that make it into the planet's interior, preventing them from reaching the core. Unfortunately, it's really hard to study Mercury up close because, well, it's so darn hot. But the more we learn about this scorched planet, the more we learn about the sun and ourselves. After all, Earth is the only place we know of that has life. But Mercury shows us what our planet might become when it leaves the habitable zone and enters a world of extremes. Thank you for watching this episode, and thank you to our supporters for making it possible. Your support allows us to explore the unknown and bring the wonders of science to everyone. If you'd like to join our amazing community of supporters, you can get started at our support page.